Some time ago, science established that the effigy on the shroud was formed by the infinitesimal erosion of the topmost surfaces of pure linen fibres that are twisted together to produce the threads of the fabric. Matter was not transferred onto the cloth by contact. Moreover, the image is thermostable. Even the parts of the image that intersect the well-known scorch marks appear unaltered. It is similar in appearance to the effect of photooxidization due to sunlight exposure. Color is more saturated where there is a greater density of altered fibers wrapped around each thread. Enlargements reveal that very few fibers are altered where the image fades. Until now, it has been accepted that the two-dimensional projections of the surface of an object are only produced when every particle of the surface emitting spherical waves of electromagnetic energy crosses a lens or diaphragm, like in photography, before meeting the projection surface. The process becomes simpler if we consider the center of the lens or diaphragm as the center of a star of lines, radiating energy. The opposite extreme is when every particle transmits energy or matter to the projection plane by direct contact. However, if energy had been transmitted through body-to-cloth contact, the image on the flattened cloth would now appear monstrously deformed. The image, therefore, was generated from a distance. If a source of energy radiates spherical waves across an object, like in radiography, the image obtained on the projection surface is a shadow of the more or less transparent matter the waves pass through. So what was the projection pattern that produced the image? Photographic negatives of the shroud disclose increasingly minute and fine details, just like a photograph of a real human body. But later we will see that the image is also similar to a radiograph, showing elements inside the body and superimposed objects. Just like photographic plates imprinted by energy radiation, the image on the shroud is similar to a photographic negative. By photographing the negative, we obtain the negative of a negative, or rather the positive image of the photograph body. As we will see, very high-resolution scans of the image reveal clear lines that allow us to identify and restitute a number of objects on the body. In projective geometry, restitution is the process that uses one, two, or more two-dimensional projections of an object, usually one, two, or more photograms, to determine the shape, size, and position of that object in space, according to a pre-established reference system. The two photographic plates used for this survey were made by the photographer Giancarlo Durante and are contact copies of two gelatin silver bromide plates created by the photographer Giuseppe Henri in 1931. They have not been subjected to any treatment or filtering, only to brightness and contrast adjustments. The first plate measures 40 by 50 centimeters and contains only the face of the human body, identified on the shroud. The second measures 40 by 19 centimeters and contains the whole cloth. On this high-resolution detail, let's mark in orange pen the clearly discernible outlines of some objects that we will shortly identify and restitute. These images are extremely important because they show the remarkably clear, flawless contours on which the identification and restitution of the body and objects are based. We will later see that these lines belong to the outline of the same object, and that radiation produced the object's image while it adopted different positions, or in other words, while it was moving. And the phenomenon is not limited to this object. There are actually dozens of often partially superimposed images of the same objects. The phenomenon revealed on the shroud is similar to the result of stroboscopic photography, which captures a rapid sequence of images of a moving object on a single frame, using a flash that emits multiple quick bursts of light. Science uses this technique to record the evolution of the phenomenon it wants to study. Restitution of the body reveals that there were no folds in the fabric when the image was formed. The cloth was laid flat along the front of the body and almost flat along the back. The body was in a prone position. The position of the hair, the hollows of the face between the cheeks and mouth, the slope of the cloth from the right leg towards the left, due to gravity, the position of the arms and wrists on a single plane, and other details, indicate that the force of gravity was towards the front of the body. The front image of the body shows the faint, slightly undulating and uneven outline of what has been established to be a strip of material tied around the waist. In the dorsal image, the strip appears undulating and wrinkled, as normally happens when fabric is tied around a body. It stretches down almost to the knees, where, as is fitting with the body's prone position, it deviates towards the right calf and vanishes just above the ankles, wedging itself between them. We will see how, like in photographs, the sharpness and intensity of the object's contours vary depending on the material they are made of. This strip of fabric immediately brings to mind the strip that today can be seen reattached to one of the longitudinal sides of the shroud. About 8 centimeters wide and 386 centimeters long, it was separated from the cloth and then carefully stitched back on again, exactly where it had been before. Its slanted ends stopped 15 centimeters from one end of the wider strip and 35 centimeters from the other. Therefore, the 2 corner segments marked in blue are missing. The strip on the effigy is between 7.8 and 8.6 centimeters wide. If we calculate that a segment wound 1½ times around the waist would measure 163 centimeters, and add 126 centimeters for the length of the front section and 97 centimeters for the back, we get a total of 386 centimeters, which is the same length as the actual side strip. Restitution shows that the strips match. Segment A on the front view of the body can now be seen as segment A, stitched back on next to the dorsal image. In keeping with the life of Jesus of Nazareth, the most likely hypothesis is that the strip was removed to support the body while it was being taken down from the cross. It would have been tied around the waist as seen on the shroud. Then the 2 ends would have been lifted up over the patibulum and knotted together behind the stipes in order to support the body once the nails were removed. Finally, a clean oblique cut beneath the knot would have let the body fall. This would explain why the ends of the reattached side strip are missing. Despite the distance in space during projection between the projected plane and the projection plane, that is, between the strip and the shroud, the image of the segment of cloth between the waist and the knees is identical to the segment of reattached cloth, demonstrating that the lines of projection, that is, the energy rays, were parallel. Our first confirmation, therefore, that we are dealing with a form of parallel projection, where the projection rays were orthogonal to the plane the shroud was laid upon. Energy radiation in parallel projection has not yet been found in nature, even though the light of the sun and stars, given their great distance from the earth, comes near to parallel projection. The image of the top cube in the photo is an orthogonal parallel projection, obtained using a particular optical system. This helps you to understand the difference between the image of the body on the shroud and the image that a normal photo would provide of the same body. The second confirmation of the projection model that generated the image comes from the detection of a piece of clothing and its belt in particular. On the front and dorsal images we can see the very faint outline of what historical research has identified as a caleçon. This was a wide band of fabric wrapped around the waist and hips to the knees. In front the ends were pulled upwards, and a wide sash hung down from the middle of the waist, slightly longer than the front of the garment. The calisson helps to explain the path of the bloodstains that descend from the chest towards the waist, and then abruptly veer to the side. When the body was in a vertical position, blood flowing from the wounds was halted and diverted by the cloth tied around the waist. Dating back to the time of Moses, the calisson was worn with a snakeskin belt. The clear linear contours of the belt tell us that it was made of a thicker, more compact material than the clothing. The horizontal edges of the belt are congruent, that is, one edge can be translated and superimposed upon the other. The consequent constancy of the AB segment between any 2 points along the edges in the direction of translation is further confirmation that the image is the result of orthogonal parallel projection. Moreover, the buckle, which due to its very clear contours is presumably made of metal, is a perfect annulus. Longitudinal axially symmetrical markings can be seen on the belt, like those on the skin of the python regus, one of the smallest African pythons. The restitution of chain segments near the wrist of the right arm is another demonstration that the projection rays were parallel. Restitution shows that these rings are all the same, and toroidal, that is, donut-shaped. The two curves forming the apparent outline of each ring have the same axis of symmetry, which only happens with parallel projection. Moreover, the side view of the lowest ring is limited to 2 semicircumferences, confirming that they are orthogonal parallel projections. Restitution of the chain rings on the back of the right calf produces the same result. Here are a few of them. Before looking at the most important outcome of this discovery, let's pause for a moment to look at one particular object. A thorny branch twisted into a crown, with leaves, flowers, and fruit, which botanists have identified as Sarcopoterium spinosum. Unlike on the front of the branch, there are formidable thorns on the back. Sarcopoterium spinosum is a thorny bush that is commonly found along the south-eastern shores of the Mediterranean as far as Tunisia. In Italy it can only be seen in Vendicari, Sicily, Sant'Elia, Sardinia, and on the eastern coast of Puglia. It flowers in spring. The leaf is made up of 9 to 15 pairs of lanceolate, dentate hairy leaflets. Very small green leaves can be seen on some of the fruits in the photo in the lower right corner. The green flowers, growing in racemes, have 4 petals and numerous fuchsia stamens. The bushes are very thick and are brightened by clusters of red cherry-like fruits, although their formidable thorns give them a menacing appearance. Restitution of much of the branch reveals the position of the thorny crown on the head, and with respect to the plane of the cloth, showing the frontal body image. It was positioned at an angle of about 88 degrees, or in other words, it was almost perpendicular to the plane. This confirms that the face was not touching the linen cloth, as the head was resting on the branch, twisted around the highest part of the forehead. However, this is incompatible with the harmonious beauty of the flowers, leaves, and fruit, which are in perfect shape and not crushed in any way. The trickles of blood from the back of the crown, placed slightly above the nape of the neck, run from the occipital towards the parietal area, providing further confirmation that the body was in a prone position. Small rings forming a short chain have been detected on the left-hand side of the face, near the crown. Restitution has shown that the profile of each of these smaller rings has a more finished appearance than the coarse, simple rings we identified earlier, suggesting a decorative rather than practical function. The small chain consists of 21 rings and descends over the eyelid and cheek, parallel to the nasal septum. The discovery of this small chain links up with the study of the image on another important ancient relic kept in Oviedo in Spain, a linen cloth measuring 85 by 52 centimetres. Apparently there is no effigy on the cloth, only patterns of bloodstains differing in intensity. There are several pairs of truncated conical perforations on the relic. The peaks of each pair of cones are on opposite sides of the cloth. The pattern of the marks suggests that we are not simply looking at an obvious symmetrical pattern, but at a much more articulated polysymmetrical organization. The study confirms the hypothesis. The marks from two multiple symmetries. The folds in the cloth are their axes. By folding the sudarium along the axes parallel to side A of the rectangle and the axes parallel to side B in 4 alternate phases, we obtain 80 layers of cloth. Hasty folding transformed the cloth into a small, very thick pad, about 57 by 114 millimeters wide and maximum 22 millimeters thick on one side and about 11 millimeters on the other. The blood permeated one of the thicker corners of the pad, simultaneously staining most of the layers. A mysterious reddish-brown figure stands out clearly on the 3 denser stains on the sudarium. It has a linear appearance and resembles the shape of the bottom of a minuscule basin on the 2 symmetrical stains, and the letter M on the 3rd stain, which stands apart in the lower right corner of the cloth. When the cloth is folded into a pad, the first 2 marks are superimposed and the third lies adjacent to them, joining the M-shaped mark to the other 2. Moreover, this composition is situated where the pad is least thick. A mark of identical shape and size is very clearly seen on the negative of the front of the shroud, above the forehead and hair, slightly to the left of the axis of the body. The mark appears in a lighter area that restitution reveals to be the image of the sudarium, folded up into a pad. One of the 2 sides showing the layers of material, the one that is deeply imbued with blood, appears even lighter. Restitution indicates that the pad was placed as a cushion between the head and the horizontal plane, the larger sides at an angle of about 58 degrees, with respect to the plane. The area soaked in blood was touching the forehead. The pad was clasped where you can see the mark on the shroud at the top end of the small chain. This leads us to identify a twisted bow fibula, initially presumed to be the fastener of a woman's bracelet, a sort of clasp used to hold the soft wad of cloth together. The fibula, which you can see enlarged here, is about 30 millimeters wide. Below are some examples of ancient fibulae. It is now possible to explain the numerous pairs of mutually inverted, truncated conical perforations on the sudarium. They were made by the fibula. When a pin pierces 2 layers of overlapping fabric, it creates 2 truncated conical holes. When the fabric is unfolded, the cone on the upper layer is overturned due to a 180 degrees rotation along the fold. In this way, the perforations appear to belong to 2 different cones, with their tips on opposite sides of the cloth. Therefore, when the pin pierced almost all of the 80 layers of linen, it created just as many pairs of perforations. When the sudarium of Oviedo is folded into a pad, the 2 superimposed marks, joined with a third, are the same shape and size as the fibula identified on the shroud. The pin passed through the layers of cloth on the side of the pad that was saturated with blood. The twisted bow, on the other hand, remained on the outside. Inside the image of the object detected on the shroud on the forehead is a more densely coloured area that is very similar in shape and size to the mark that can be seen on the sudarium of Oviedo when it is folded into a pad. The similar contours of the 2 objects, of the mark and the fibula, lead us to believe that they belong to the same object. It would be useful to carry out a direct examination of the sudarium of Oviedo to verify the position and number of pairs of perforations made by the fibula pin. The survey of the strip tied around the waist, the calisson, the branch, the chains, and the sudarium folded into a pad and fastened with a small chain, encourages us to further our survey and restitution investigations, which is likely to be a monumental task, scanning very small areas at a very high resolution. However, even without high-resolution scanning, it will escape no one's attention how the arms on the front image of the body appear to be in an anomalous position. The symmetry of the body with respect to the longitudinal axis is in sharp contrast to the asymmetry of the hands. The arms are symmetrical as far as the wrists, but the right hand is decidedly lower than the left. Let's look at the area in the yellow square. Firstly, at the fingers on the right hand in the lower half. Examination of the fingers produces an unexpected result. The anatomical configuration of the right hand demonstrates that the arm was already significantly detached from the shroud surface, and the wrist was almost perpendicular to it during the emission of radiation. The index and middle fingers are extended, while the ring finger and little finger are bent towards the palm, with the second and third phalanges clearly visible. The thumb is also bent in towards the palm, and therefore is mostly concealed by the hand. The third phalanx can be seen protruding between the middle and ring fingers, the fingernail also, although this is facing towards the stomach. Therefore, the body tissues prove to be transparent to radiation emitted by the body. Let's now look at the rest of the area inside the yellow square. The same right hand is seen in a different position. This time it is clenched in a fist. This is the first very important manifestation of the phenomenon that we initially compared to the stroboscopic effect of modern photography. In fact, between these two positions we can see fragments of other positions that the same right hand adopted. Examining the fist, we can see the outline of something resembling a small band of material wrapped around the middle of the thumb. The band has distinct congruent contours, meaning that one side can be exactly superimposed on the other. Moreover, it attenuates the intensity of the image of the finger more than the fabric we identified earlier. Therefore, it is made of a thicker material that is more opaque to radiation than the linen. Later we will identify the object and explain the reason for the hand movement. In the meantime, the observation that this anatomical configuration of the hand indicates a muscular effort, therefore a voluntary movement, is extremely important. This extraordinary discovery that the images were produced by consecutive bursts of energy, and that they show the different positions the right hand adopted during movement, completely overturns established ideas, opening up a new way of viewing the content the relic has transported through time. There is not one image on the shroud, but rather multiple images that were superimposed on top of each other on the same photogram during a few seconds of energy transmission. For this reason, the image is clear in some areas, hazy and indistinct in others, as if submerged in a fog that blurs our vision. Due to the complexity of the phenomenon, survey and restitution now appears to be a colossal undertaking, but one that is nevertheless feasible when examined from a totally new perspective that will help to clear the fog. Some objects help more than others. These are the metal elements, like the nails. As they are fairly big, the images of them are sharp and their contours are distinct. Along with the other objects, they help us to understand what happened in those few seconds. One of these objects can be seen between the two outermost images of the right hand. The outline of the cigar-shaped image is blurred, but high resolution reveals the clear and linear contours of a nail inside, which restitution shows to be square-sectioned, with a shaft that tapers from the head towards the point in a pyramid shape. Next to the head of the nail are some of the many adjacent distinct and often partially superimposed images of the same nail head that were left by the movement that occurred during the transmission of energy. These allow us to restitute the various positions of the nail. A similar situation is seen on the left hand. Again, the corrugated contours of a cigar-shaped object can be seen, with one end in the well-known dense bloodstain on the shroud near the image of the wrist. And inside we see the linear contours that allow us to restitute another nail, similar in shape and size to the previous one. The corrugated contours at the sides of the nail, the upper end corresponding perfectly with the hole the blood spilled from, to leave the stain and the type of radiation, which we will deal with later, suggests that the object containing the nail is the hole it produced. Therefore it is likely that also the nail on the right hand, which has the same corrugated contours at the sides, was still inside the hole during the transmission of energy that left an imprint of it. Meanwhile, it is important to note that next to the image of the nail on the left hand are other similar images of the same nail. They are almost parallel to the first and partly superimposed. Another image, probably of the same nail, was detected directly above the wrist of the left hand. This time, however, it has much clearer contours, which suggests that it was outside the hand. Restitution reveals that the actual length of the shaft is 125 mm, and the point 9 mm, while the sides of the square head are about 9 mm. Also, the left hand moved downwards, and this too was a voluntary movement, as we shall shortly see when we examine an object it loosened. Fragments of intermediate positions are shown below, by the fingernails especially, which appear to the left of the final position of the hand. The movement, and especially the position adopted by the hand, are highlighted in particular by the conspicuous trickle of blood that was discharged from the hole made by the nail. This stain, which was initially left on the shroud through direct contact when the blood soaked the weave of the fabric, can now only be seen as a faint ochre hue of its projection. These hand movements displaced the objects that were tied to them. The blood-stained chain detected near the right wrist can be seen lower down, ending up at almost a right angle to the longitudinal axis of the body. The rings are identical to those observed in the first position, once again confirming that the images are the result of parallel projection, orthogonal to the plane of the cloth. Subsequently, another object, even more unexpected than the chains, was detected and identified. A slip knot on a small strap with distinct linear contours, the knot held between the ring and middle fingers of the left hand placed in the initial position. The same strap can be detected in many other positions, together with a small cube-shaped box. This object has been identified as a tefillah. Tefillin are pairs of tefillah. They are ancient Jewish objects of religious significance, worn by men only. One is wound around the left arm, and the other is tied tightly around the head with leather straps. Each strap holds a leather cube-shaped box containing 4 scrolls of biblical passages. This is a literal interpretation of the biblical command to bind the divine word around the arm near to the heart, and between the eyes close to the mind. It is important to note that the knot on the tefillah on the left, the one to be tied to the head, is different to the knot, a slip knot, on the one that should be bound to the left arm. The drawing shows how, for the Jewish religion, the 2 tefillah should be worn. You can see the slip knot on the outside of the left bicep, and the complex way the straps are wound all the way down the arm to the middle finger. The tefillah strap has been identified in several different positions around the hands. Only a few of them are shown here. High-resolution scanning shows clear contours that allow us to determine that the strap is 21 mm wide. Moreover, a number of identical, probably pierced, embellishments can be seen inside the strap, which restitution reveals to be rhombus-shaped. In this same strap, it is now possible to identify the object that is wrapped around the thumb of the right hand, clenched in a fist. A tefillah strap can also be seen lower down on the right hand, wrapped around the index and middle finger. It has the same characteristics as the aforementioned strap, but appears to be rolled into a cylinder at one end. Inside we can once again see the pierced, rhombus-shaped embellishment. The same section of strap, wrapped around the upper part of the index and middle fingers of the right hand, is seen in a sequence of different positions, apparently linked to the various positions adopted by the hand, and always with the same cylindrical end and rhombus-shaped piercing. A survey of the left arm shows the tefillah strap wound as tradition prescribes, a number of times around the forearm, back of the hand and fingers. Here are only a few of the numerous positions that have been detected, showing the strap initially tied tightly around the arm, and then gradually unwinding as it moves down towards the lower part of the body. However, it was the images of the small box on the upper part of the forearm that allowed us to identify the object. Restitution demonstrates that these cube-shaped objects are all exactly the same size and have a circular decoration in the middle of the face opposite the base. Some images showing a clear series of positions are partly superimposed on each other, like in stroboscopic photography, and because they are evidence of the object's movements, they could provide information on the bursts of energy that impressed the image on the cloth. Other images illustrating the movement of the tefillah box on the left arm correspond with the various positions of the left hand, indicating that this hand moved the tefillah downwards, loosening the object from the arm it was tied to. Several images of the tefillah strap that, according to the Jewish faith, should be tied above the forehead can be seen on the face on the shroud. Many are at a slight angle with respect to the axis of symmetry of the face, and the sequence of rectilinear contours indicates that traction was applied. Those that are in a more oblique position appear less taut. Then there are other images which are almost superimposed of the object positioned transversely across the axis, above the eyes. Once again the contours of the strap are distinct, and it has the same rhombus-shaped decoration. At the centre, a tefillah box can be seen on one of the oblique strap images. Again the box appears to be perfectly cube-shaped and set on a square base, as Jewish tradition prescribes. The image of the box is attenuated by the images of the strap. In the centre of the face opposite the base of the box, which is a perfect square, as it is positioned on a plane parallel to the plane of the shroud, we see a circular embellishment surrounded by 12 lobes. This is one of the positions the box adopted while the strap moved it downwards. Some of the positions restituted by the images on the forehead give us some preliminary information about the trajectory the box followed. From its initial high position, correctly placed on the axis of the face, it translates downwards for a short distance, and then tilts away from the axis before turning back towards the arch of the eyebrow. Also, the small chain that we detected earlier on the face can be seen in different, less distinct positions. Next, high-resolution scanning allows the restitution of a small hexagonal object on the end of the chain. This suggests that the chain is a bracelet or earring with a pendant. The fact that it has been identified in several different positions reveals that there was an oscillating movement during the emission of energy that oxidized the cloth. Restitution of the hexagonal object obtained from the sharper images reveals that the pendant was probably a semi-precious or precious stone mounted on metal, given the sharpness and perfection of its contours. The stone has a regular hexagonal pyramid-shaped base and 6 thin rectangular lateral edges. Here is the reconstruction of the pendant. Radiation passes through objects and produces an image of them. Therefore, the energy that left an imprint on the cloth of the shroud also passed through the strip of linen tied around the waist, that today we can see sewn back onto where it had been torn off. And before leaving an imprint of the strip on the cloth, it must have imprinted on the strip the image of the part of the body the projection rays passed through. For this reason, we compared section 1 of the strip image on the hands area with section 2 of the actual strip reattached in its present position, more or less at the level of the waist on the dorsal image of the body. The whole section under examination of the reattached strip is full of often repeatedly superimposed images formed by radiation. The buckle of the caleçon belt, placed on a surface parallel to the cloth, shows up at the top of this image. Its shape, size and position correspond with the data obtained by restitution based on the main image on the shroud. Below we can see more images of the buckle lying in different positions. These show the buckle's movement and how it turned with respect to its initial position. In orthogonal projection, 2 coplanar concentric circles in space are projected onto the image plane as 2 homothetic ellipses, forming an elliptical crown. Therefore, when enlarged, the inner circle can be superimposed onto the outer circle. 1 diameter of every circumference is projected in the major axis of the relative ellipsis. So, inversely, the major axes of the ellipses provide the actual diameters of the circumferences they are the projection of. In this way, restitution shows that the major axes of the 2 ellipses are identical to the diameters of the circumferences of the buckle on the caleçon belt. In one image, we can also see the pin of the buckle stretched along a diameter of the inner ellipsis, corresponding to a diameter of the actual inner circumference. The tip of another finger can be seen a short distance from the little finger of the right hand. This too is mostly hidden by the unidentified object. Then, in many different directions, the outlines of linear objects resembling the tefillin straps, some of which can be identified thanks to the rhombus-shaped decoration. This confirms that the reattached strip, which has still to be examined in its entirety, is the same strip that was wound round the waist of the man who shows all the characteristics of being Jesus of Nazareth. Let's go back once more to the images of the body. Like the hands, also the feet show a clear anomaly. The position of the soles of the feet on the dorsal body image is not compatible with the position of the legs. In particular, the left sole is clearly displaced to the left with respect to the position of the leg. Actually, the correct positions are also visible, but the images of them are very faint. Moreover, the area around the feet is particularly full of superimposed images. More extensive studies will be necessary to detect all the positions of the different objects that movement and gravity shifted towards the feet. However, The investigations conducted so far have presented one initial result for us to ponder over. This is the restitution of a nail on the right foot. Again, the nail has a square-sectioned, tapering shaft, like the other two nails on the hands. The point of the nail has been detected in many different positions near the heel. Let's look at one more closely. Several images in very different positions also appear further down. This is evidence of the nail's movements, first turned at a slight angle, then lower down, almost at a right angle to its initial position. The images are very close together and always superimposed. In alignment with the first image, we can see the hole with the nail still inside, and many more adjacent and superimposed images of the point. Then, alongside, a clear image of the nail overturned. It is important to understand why, during this sequence, we unexpectedly see the nail overturned, with a pyramid-shaped point on a hexagonal rather than square base. Let's look at this drawing. The cloth is laid over the sole of the foot, but because of the presence of the nail, the fabric is lifted up over the point before dropping down to cling to the sole again. Radiation coming from within the body is perpendicular to the plane and is oriented upwards, so that it oxidizes the segment of the linen marked in red. When the point retracts and the cloth flattens out, the segment in red moves over the entrance of the hole, and the image on the cloth shows the point facing downwards. Because the portion of the cloth covering the pyramid-shaped point has a bigger surface than the 4 triangular faces, it displays another 2 triangular portions, which first encircle 2 opposite corners of the pyramid and appear when the cloth is spread out on a plane. The nail image widens towards the point, because the cloth, which had initially been lifted by the point to form 2 planes like a sloping roof, now lies on a single plane. If we follow the sequence of images of the point, we can see that at the entrance of the hole it is orthogonally projected onto a plane, like all the other images of the body and of the objects we detected, and pointing upwards. This means that the cloth is now flat, and the foot is turned in such a way that the sole is less inclined with respect to the horizontal plane. Radiation emanating from the body is now directed downwards, and the nail image shows the point turned towards the heel. Therefore, in relation to the whole body, from the feet towards the head, hence upwards. The foot has rotated about 90 degrees, and during this rotation the nail appears to have retreated back into the hole. What we have illustrated here explains why, in the dorsal image of the body, the most discernible position of the soles of the feet is incongruent with the position of the legs. Restitution of a sequence of positions of the right foot has allowed us to analyze its movements and affirm that the image of the leg was formed before the image of the sole of the foot. A nail similar to the ones we identified earlier can be seen on the left foot, but in this case without most of the point. The nail is orthogonally projected onto a plane, and what remains of the point is turned towards the heel. Therefore, like the right foot, the left foot rotated about 90 degrees, to end up in a horizontal position. The nail is still inside the hole. More images of the calisson belt can be seen around its clearest image, some above and others below it. The prostrate position of the body, with the wrists crossed, would have impeded chest expansion. Therefore, the belt's movements may be related to the 2 phases of abdominal breathing. All the results obtained from the survey are essential for identifying the radiation pattern that produced the images of the body and the objects. First of all, they demonstrate that the images were produced by orthogonal parallel projection onto the plane of the part of the cloth containing the image of the front of the body. Secondly, that the radiation that produced both the front and back images of the body had two opposite orientations. They also demonstrate that the energy emanated from the body. This is confirmed by the absence of images of objects outside the body contours. However, the results also show that the projection pattern of energy emission remained immobile, while the body, and therefore also the objects in contact with it, moved. This means that the energy did emanate from the body, but that it comes from an infinite source that always radiates in the same direction with two opposite orientations. At this point, we come up against the limitations of the geometric notions we have used until now, related to our earthly world. To understand the origin of the radiation projection pattern, we have to extend projective geometry to the macro and microcosm. Like physics, the geometric notions we use to explain terrestrial phenomena are no longer sufficient in the macro and microcosm. In these spaces, the notion of the straight line is no longer acceptable, because in an absolute sense, that is, in the absence of an observer, that every line is in actual fact a circumference. We can still rely on the notion of the straight line to portray phenomena close to us, but in order to represent the immense expanses of the microcosm and macrocosm, we are compelled to think exclusively in terms of circumferences. Therefore, for the human observer, Euclidean lines can be called maximum circumferences. So energy is emitted from a source on a maximum circumference in two opposite directions, before meeting again at any point on the same circumference. Consequently, this point receives energy from two opposite orientations. Parallel lines in our earthly world are in actual fact maximum circumferences with the same point in common, the centre of projection in the case of a source of energy. However, projective geometry also demonstrates that the radiating source can equally be far off in the macrocosm or in the microcosm, because these spaces, macrocosm and microcosm, divided by a closed surface, like a sphere or the body of the shroud, are, in an absolute sense, equivalent. So a distant source in the microcosm inside the body irradiates in two opposite orientations, just like a distant source in the macrocosm outside the body. This is a projection pattern that explains how radiation reached and oxidized the linen cloth. What we have described here is what science based on a projective geometry has demonstrated so far. The study of the phenomenon opens up vast new areas of research of mutual interest to projective geometry and physics, which will likely have a major impact on all branches of knowledge, and therefore on our very existence. The Shroud is a book of science about a world as yet unknown to us, a book of science that man has just opened.